In this video, we are gonna flip it around. The last video, I gave you names. We figured out what the formula is. What if I give you the formula? How do you figure out what the name is? It's super easy if you know your elements, if you know the names of the elements, if you can recognize the symbol and know the name, you'll be able to do this very easily, especially if the ionic compound or the formula I give you is a fixed charge metal. So when you look at something like this, you notice that this is aluminum. Aluminum is a fixed charge metal. So all you have to do is just name the metal and then name the non-metal and write "ide" at the end. That's it. Or the stem of the non-metal and then "ide." And you don't have to worry about any of these subscripts or anything like that. You don't have to worry about charges. If it's a fixed charge metal, super easy to do this. So this is fixed charge. So all you do is write aluminum sulfide. And how do you know that it's fixed charge? Because I gave them to you and you've memorized them. Group 1A, Group 2A, aluminum, gallium, zinc, cadmium, and silver are the fixed charge metals. Just remember that. For those, you don't need any Roman numeral in the name. Really easy to figure out the name from the formula. This is calcium. It's a fixed charge metal. Calcium chloride. Simple as that. Calcium chloride. Zinc. Zinc is a fixed charge metal. Zinc oxide. Okay, come down here. Barium, you recognize this as a fixed charge metal. Again, you really need to know the atomic symbols. I'm not kidding about this. You have to become comfortable with these things in order to do chemistry. So this is barium, fixed charge metal, barium nitride. And one more time, how do you know that they are fixed charge? Because group 1A is fixed charge, group 2A is fixed charge, aluminum, gallium, zinc, cadmium, silver. Okay, those are fixed charge. All other metals, variable charge. Okay, so like I told you, these are super easy. Now, when you get a formula that has a variable charge metal in it, not quite as easy because you have to tell me what charge metal it is. You can't just say iron oxide. You have to tell me what charge, which iron is it? And you have to use a Roman numeral in the name. So when you have a formula and you have to figure out the name of the ionic compound, don't forget you must use Roman numerals in the name, not the formula, the name of the formula let's see, how do I say? The name of ionic compounds that have variable charge metals. Okay? So let's say I have this. Okay? You look at it and you want to say iron oxide, Dr. Robbie, but no, you've got to tell me which iron it is. Remember how I told you you could have iron as +2 or +3. Which one is it? This is the technique I always teach my students. It works really well. What you do is you do a dotted line between the metal and the non-metal. And then you say, all right, what is the charge of the non-metal? You know that oxide is -2. It will always be -2. So this side has to balance this side. Because remember, ionic compounds are always neutral. There's no plus, there's no minus. It's always the pluses and the minuses cancel each other out. So if this side is -2, this side has to be +2. And there's only one of them, so that one iron must be +2. So this is iron, Roman numeral 2, oxide. See what I'm doing? Okay, let's do another one. Let's say I've got this thing here. a little trickier. Okay, I recognize that copper is a variable charge metal. Now, instinctively, a lot of students will look at this and say, oh, that's definitely, it's copper too, but no, use the technique. Dotted line. What's the charge on the non-metal side? The sulfide, just like oxide in group 6A, is -2. So if this side of the dotted line is -2, this side of the dotted line has to be +2. But here's the difference between this one and this one. Here there was only one iron. Here there are two coppers. So each one of them is +1. +1 times two of them gives you the +2. So each copper is a +1. So therefore this is copper Roman numeral 1 sulfide. And what we did was we went 2 divided by 2. Because we have 2 on this side, you have to divide by 2. Divide the charge by this number. Okay? So that's why it's 2 divided by 2 is 1 copper Roman numeral 1 sulfide. Okay, let me do another one down here. Let's say I've got this. Okay, again, you can't say iron chloride. You have to tell me which iron it is. Dotted line. What is the charge on a chloride? One chloride is -1, but I have 2 of them. So on this side you multiply, this side you divide. You have 2 of them. So 2 times -1 is -2, because each one of them is -1. So this side is going to be +2. Remember, they have to cancel each other out. There's only one iron here, so this iron must be Roman numeral 2. Iron, Roman numeral 2, chloride. Okay, this dotted line technique works beautifully. I'll give you a few more to practice with, and then we can move on to the last video, which is the polyatomic ions. Okay, so a couple more formulas. So let's say I've got, and I'm choosing on purpose the variable charge metals because they're the ones that you have to put a Roman numeral with. So let's say I've got this, or I have this. Okay, so I have 3 variable charge metals. This is tin, this is iron, and this one is gold. It's not silver, it's gold. And I know I never gave you the charge of gold, but you can figure it out based on what we're doing today. All right, so let's start off with this one. You cannot call it tin sulfide. Why not? Because it's variable charge. You have to tell me with a Roman numeral which tin this is. So dotted line. Sulfide is -2, right? Sulfide is a group 6A, just like oxygen, sulfur, selenium. So sulfide is -2, but I have 2 of them. So -2 times 2 is -4. Do you see where I'm getting the -4 from? Each sulfide is -2, but I have 2 of them. So -2 times 2 is -4. So if this side of the dotted line is -4, this side of the dotted line has to be +4. I only have 1 of them. I don't have more than that. So I multiply you on this side, you divide on this side. But this is only 1, so divide by 1 is still +4. So this is tin, Roman numeral 4, sulfide. Okay, you got to practice, guys. This is not where none of us are born knowing how to do this. The only reason anyone learns how to do this is they practice. Okay, you can tell that iron is a variable charge metal. Dotted line. We're going to do a whole bunch of multiplication and division here. All right, what is the charge on an oxide? One oxide is -2. but I have 3 of them. So minus 2 times 3 is minus 6. So if this side of the dotted line is minus 6, this side has to be plus 6. Why? Because they have to cancel each other out. Remember how I said ionic compound has to be completely neutral. No minuses, no pluses, cancel each other out. They have to cancel. Okay, so if this is plus 6, I have 2 irons, not just one of them, 2. So it'd be 6 divided by 2. Remember, this side it was minus 2 times 3 was minus 6. 6 plus 6 divided by 2 is plus 3, so that immediately tells you that this is iron, Roman numeral 3, oxide. Okay? Gold, we have no idea what the charge of gold is. No problem, we can figure it out. Dotted line. Selenide is just like sulfide and oxide, it's minus 2. I only have one of them, so I'm going to put a minus 2 here. So that means this side has to be plus 2. Cancel each other out. But I have 2 of them. So 2 divided by 2 is 1. Each gold is plus 1. So you write down gold. Gold is one of those elements that's named after, that the symbol is comes from aurum, not an English name. Okay, gold, Roman numeral 1, selenide. Okay. Good. Little trickier than ones with fixed charge metals, but definitely doable. All right, next videos we'll be talking about polyatomic ions.